In the last class we discussed this example for unpaired t-test. So today we are also going to discuss this formula with a different method of calculation. So after having this example, what we'll do is the very next step is to framing the null hypothesis. So in the last class we already framed the null hypothesis, and the next step is to doing the calculation as x variable, y variable, and finding x and x bars value, y and y bar value, and after that this finding the standard error, standard deviation. We have had this separately, calculating group A's and group B's separately, then doing the standard error after finding out the standard deviation. So I said that another method of calculating standard error or else standard deviation. So we another formula for calculating standard error is equal to combined standard deviation into square root of 1 divided by n1 plus 1 divided by n2. So this is our actual formula. So next we need to know that combined standard deviation formula. So for combined standard deviation we have a formula as square root n1 sigma 1 square plus n2 sigma 2 square divided by n1 plus n2 minus 2. So we have this value and this value in the last class only. So combined standard deviation is equal to n1 we have as 13, and this summation sigma 1, which is nothing but total value of sigma 1 value is total 1 standard deviation 1 as summation of x minus x bar whole square divided by n. What after calculation, what final value we have got, this is nothing but our sigma 1's value. So we'll put that sigma 1 value in this formula of 1.54 whole square plus n2, which is nothing but 12. So similarly we have this summation standard deviation 2, which is nothing but sigma 2 or summation of x y minus y bar whole square divided by n. We have got the value of 0.95. So we'll write down this 0.95 whole square divided by 13 plus 12 minus 2. So combined standard deviation is equal to, after simplifying this we'll get around 30.83 plus 10.83 divided by 23. So again we'll simplify this, we'll get around 1.811, which is nothing but combined standard deviation is equal to 1.34. So our next step, we have got combined standard deviation. Next, in the standard error formula, directly we'll put this value and however we know this value, and we'll put that and we'll get the standard error value as standard error is equal to combined standard deviation. We have 1.34, and by multiplying this 1 by 13 plus 1 by 12. So we'll get 1.34 into square root of 0.15. So after simplifying this, 1.34 plus 0.39, which is equal to 0.5. This is not plus here, this is multiplication. So after multiplying this, we'll get around 0.5. So next step is finding the degree of freedom, and we have got the standard error. We need to put this in the table. The difference mean we know, and similarly we need to put standard error formula followed by table value. Calculated table value is 3. We'll get a table value as 3 for this also, followed by the next step finding degree of freedom and the level of significance. We need to find the critical value. We'll get this, and followed by what we need to do is we need to frame the inference, and after that H0 is rejected. For that we need to frame an H alpha or HA, so that here we'll finish it out. Thank you.